Look up at the night sky. See all those twinkling stars? Every single one of them, along with every star you can't see, has a death sentence. And it's not just the stars. One day, the universe itself, as we know it, will become cold, dark, and empty. But what does that end really look like? How long will it take? Today, we're going on an incredible journey, not just billions, but trillions of years into the future, to witness the final moments of the cosmos and the death of the very last star. Right now, we live in what astronomers call the stelliferous age of stars. It's a brilliant, vibrant time. Gas clouds collapse to form new suns. Galaxies collide in spectacular fireworks displays. And at least on one tiny blue planet, life has emerged to ponder it all. This era began about 100 million years after the Big Bang, and has been going strong for over 13 billion years. But it can't last forever. The universe is expanding, and it's expanding at an accelerating rate. This expansion is pulling everything apart. Galaxies are rushing away from each other, and the fuel for new stars' vast clouds of hydrogen gases being used up far faster than it can be replaced. Let's fast forward a bit. In about 4.5 billion years, our own Milky Way galaxy is on a collision course with our neighbor, Andromeda. It won't be a destructive crash like a car accident, but a slow, majestic merger over hundreds of millions of years. The night sky for any far future inhabitants of our solar system would be a breathtaking spectacle of swirling stars and gas, eventually settling into a new, larger galaxy some call This merger will temporarily kickstart a new wave of star formation, a final burst of cosmic creativity, but it's a fleeting renaissance. Now, let's jump much, much further ahead. 100 billion years from now, the universe's expansion has become extreme. All other galaxies, except for those in our local group gravitationally bound to Milkameda, will have been pushed beyond our cosmic horizon. From our vantage point, the sky would be almost completely black, save for the stars of our own galaxy. The rest of the universe would be invisible to us, lost forever in the expanding darkness. It would be a lonely existence. BTI's point star formation has almost completely ceased. The universe is running on fumes. The only stars left are the smallest, faintest, and most frugal ones, the red dwarfs. These stars are the universe's ultimate survivalists. While a star like our Sun burns through its fuel in about 10 billion years, a red dwarf, being much smaller and cooler, sips its hydrogen fuel incredibly slowly. They can live for trillions of years. They are the final beacons of light in a rapidly darkening cosmos. And this brings us to our ultimate destination, 100 trillion years into the future. Imagine a universe so old that our current 13.8 billion year age is just a rounding error, a fleeting moment in its infancy. By now, every sun-like star has long since died, leaving behind a white dwarf. Every massive star has gone supernova, leaving behind a neutron star or a black hole. The only stars still shining are the red dwarfs. But even their time is finally running out. For trillions of years, they have glowed faintly, bathing their dead solar systems in a dim, ruddy light. But one by one, they exhaust the last of their hydrogen fuel. Unlike larger stars, red dwarfs don't swell up into red giants or explode in supernova. They are too small for that. Instead, they just fade. They slowly contract and heat up, briefly becoming blue dwarfs, before their nuclear fires extinguish completely. They become white dwarfs, ultra-dense balls of carbon and oxygen that no longer produce their own light or heat. Picture the scene. The last red dwarf in the universe is dying. For trillions of years, it was a tiny spark in an infinite blackness. Now, its core sputters, its faint light, the last light from any star, flickers and dies. With its final breath, the stelliferous age of stars, over the universe is plunged into a new, unimaginably long epoch. The degenerate era. The cosmos is now a graveyard of stellar remnants. It's filled with black holes, neutron stars, and countless cold, black dwarfs, the corpses of stars like our Sun and the red dwarfs. The universe is almost entirely dark and incredibly cold, just a few degrees above absolute zero. Yet, even in this profound darkness, things still happen, just on timescales that are almost impossible for us to comprehend. Galaxies themselves begin to dissolve over quintillions of years. The gravitational dance between the dead stars within the Milky Galaxy will cause it to slowly evaporate. Most black dwarfs and neutron stars will be flung out into the desolate void of intergalactic space. The rest will spiral inward, towards the supermassive black hole at the galactic center, adding to its mass. So, is that it? Is a cold, dark, empty void the ultimate fate? Two mind-bending processes might still be at play. The first is proton decay. Some theories of particle physics suggest that protons, the building blocks of matter, are not truly stable and will eventually decay. The timescale for this is immense, something like 10 to the power of 37 years or more. If this is true, then all the black dwarfs and neutron stars will slowly dissolve into a sea of low-energy particles and radiation. Matter as we know it would cease to exist. And what about the black holes? They are the last major players on the cosmic stage. But even they are not eternal. Thanks to Stephen Hawking, we know about Hawking radiation, a process where black holes slowly lose mass over unimaginable times. A solar mass black hole would take 10 to the power of 67 years to evaporate. The supermassive black holes at the centers of galaxies. They could last for a Gugatha 10 to the power of 100 years. As these final black holes evaporate in a final, weak flash of light and particles, the universe enters its last conceivable stage, the heat, death, or the dark era. It will be a near-perfect vacuum, unimaginably vast and empty, populated only by a sparse mist of photons, neutrinos, and other fundamental particles, all drifting aimlessly. The universe will have reached a state of maximum entropy, where no work can be done, no structures can form, and no complexity can exist. Time itself may lose its meaning. It's a sobering thought, isn't it? That everything we see, all the brilliance and wonder of the cosmos, is temporary. But there's also something beautiful about it. It makes this moment, right now, in the vibrant, star-filled youth of the universe, incredibly precious. We are living in the cosmic dawn, a brief, brilliant window of time when the universe is alive with light, energy, and the potential for life. We are privileged to be here to witness it, to ask these questions, and to marvel at the grand, cosmic story of which we are a tiny, but meaningful part. Thank you so much for joining me on this journey to the end of time. It's a heavy topic, but I find it absolutely fascinating. What do you think about this far-flung future? Let me know your thoughts in the comments below. And if you enjoyed this cosmic exploration, please consider hitting that like button and subscribing for more journeys into the wonders of our universe. Until next time, keep looking up.